Thank you for coming, everybody. Today we'll be talking about vector search over complex data and actually making vector-powered systems work, hopefully bringing them to production, creating business value and all that good stuff. I'm Daniel. I'm CEO of a company called Superlinked, and I'll explain what, and it's a part of your vector search system. All right, let's get this started. I'll start with one stat to kick us off. The Algolia, Algolia search, often e-commerce search. They have 17,000 customers, billions, hundreds of billions of queries per month. The CTO said that 6 months after ChatGPT launched, they saw doubling of the number of keywords in typical queries, right? People are getting trained on running complicated queries. When you give people a search box, they'll type in a bunch of things, and they expect that your system can deal with that, right? So that's the problem. How do we make that happen? Because we kind of have to now. Okay, so let's take a step back, and before we get to like really complicated queries, let's talk about this one, right? This seems like reasonably simple. We should be able to get this done. And so, let's say our user types in recent news about crop yield. Okay, this is a natural language query. Somehow this query talks about some numerical aspect of the data, recent, right? Recent is something that refers to like a timestamp, and then crop yield refers to some kind of topic, right? So let's say a user comes in and types a query like this into our system. What can we do about this kind of query? Okay, so, well, the first thing you'll probably think about, or anybody will think about, is, okay, we'll just make a SQL statement, and there'll be some kind of filter on the time, right? Maybe it's within last 7 days, the news has been published, and we'll do some kind of keyword lookup for crop yield, right? Maybe this is where we will start, and these will be filters, right? And like this whole vector search sort of movement so far has been about dealing with the crop yield part of the query, right? Like, what if it's not exactly mentioning crop yield? Can we still find good news? Okay, well, turns out that you can use a language encoder to process the articles, turn them into vectors. You can do the same thing to the query. You can calculate cosine similarity between those vectors, and you can order your query by this cosine similarity. And somehow this works pretty well, right? So this should be nothing new. This is like everybody is following, very easy, right? Cool. But what about this part, right? Is this the best we can do to satisfy a signal that asks for recent news? What could be the problem with us doing this kind of filter? And when you think about it, what does recent mean, right? What does recent mean in the context of crop yield? So this is like some Google trend chart, right? And people search for crop yield over time, and there are probably some seasons in crop, right? Probably that has to do with time. It actually is not very clear at all what people mean by recent, right? And it's very naive to hope to capture that with the filter that says, okay, anything older than 7 days is not recent, and we just cut it off, right? So, not so easy, right? And so, okay, well, probably it shouldn't be a filter then. Probably we need to somehow order by time and the cosine, right? Probably we want to somehow combine the recent and the relevant. And so, cool, like SQL has a feature for that. It's called order by, right? We'll order by cosine, and then we'll order by the timestamp, and everything is great, right? So, okay, that's the end of the talk. We have solved all our problems, except like anybody who has written a SQL query knows that this doesn't work, right? Because the way order by works is that, it doesn't actually blend the objectives. It sorts by first, and then the items that have the same cosine similarity are sorted by the timestamp. So this is like a good impulse, but it doesn't work, right? And so basically the rest of my talk is like, how do we get this to work? Right? Okay. And so what do you do once you realize that, okay, maybe this is not so simple? Typically, people split their process into two steps. They'll generate candidates, and they'll apply some kind of ranking function to the candidates, right? They'll blend some scores, and they'll reorder the candidates, and then that's how you'll get the top results, right? And then probably you have to insert some kind of limit, limit 100 to generate, or limit 1,000 to generate 1,000 candidates, and then reorder those. Well, what's the problem with that? First of all, the filter, if a piece of news is 8 days old, you'll drop it, right? So you'll completely lose a bunch of your index. And if the result that maximizes the blended score is not in the first 1,000 candidates by the cosine similarity ordering, you'll also miss it, and it will not show up in the results. So this kind of two-stage process is super limited. And that was like the simplest query I could think about, right? Like normally the user comes in and starts to ask these complicated questions, and there are just like more and more filters and more scoring rules, and it just gets worse from there, right? So recent popular trustworthy news about crypto yield, crop yield. And what happens is that you are kind of calculating with your filters this sort of intersection of sets, right? And basically you filter everything out because those sets, if you end a bunch of filters together, you'll end up with nothing, and that's a problem. The way you should think about these things is more like optimization function, right? You should think about some space of news that has different dimensions, right? It has the dimension of freshness or recency and popularity and trustworthiness and the topics involved in those news and so on. It's some kind of space, right? This is what vectors are all about. It's like, how can we represent the space we are searching through as this kind of multivariate problem? Okay, so summarizing the progress, let's lock in the progress we've made so far. Filters and hybrid search, bad idea. Sometimes you need them, right? Sometimes certain users cannot see certain items, so filter them out. But not for this kind of optimization, it doesn't work. And then re-ranking has limitations and increases latency as you generate more and more candidates. So also bad idea. So basically, the way to make these kind of search over complex data work is to somehow solve the problem purely through vectors, right? Okay, so how do we do that? Well, in principle, you will be building something like this, right? You have your news database, and you want to encode each piece of news into a news vector, and you want to encode everything you know about the piece of news into the vector, and you want to do the same thing to the query somehow, and then you want to match the vectors in the middle, right? This is like, it's pretty clear, right? And so what will you do as the okay, so you realize this, right? We are going through the journey of actually making this work. Okay, so you realize you need to encode all your stuff to vectors. And so the first thing people try is that they grab their news object, they stringify it, right? They concatenate all the scores, they make one big string out of it and embed it with the language encoder. And then they do the same thing to the query, right? To match the two together. So this way you do encode your data and your queries to vectors, but it's a very bad idea, actually, because you are trying to encode numbers and timestamps and other kinds of data with the language encoder, and this basically doesn't work. And I have a very simple representation of exactly how it doesn't work. So in this setup, I generated 100 strings that are structured as popularity :0, popularity :1. That's the data, right? And then I have a query, high popularity. Okay, I embed both the items and the query with the latest OpenAI embedding model, make vectors, and then just find search with the high popularity vector in the data set. And you would kind of hope, right, that the popularity 99 and 98 and so on show up in the results, right? Highly popular items. This popularity 1 in there. right? This doesn't work. And so, okay, like some of the above 90 items actually showed up, but it's like total mess, right? So please don't stringify numbers and encode them with the language model. It's bad idea. Now you could ask, okay, why is it such a mess? Like, can we actually see the underlying scores? Well, I'm glad you asked. Those are the scores. And the orange dots are the results in the top 10. Okay, not great, right? Okay, so you have two remaining options here. Okay, we established you need to encode your data and your queries to vectors, because otherwise you don't get a fine-grained way to combine your objectives. And now you have two ways to do it, besides just stringifying and encoding with the language model, which doesn't work. So you can build your own encoders. You can feature engineer your data. You can make an embedding model from scratch. You need enough data to do it, and ML people and so on. Or you can somehow try to wrestle the pre-trained models that can understand different types of data to stitch together a beautiful vector that describes everything. Those are the two options, basically. And that one is too difficult. Okay, so maybe let's at least not start with the custom embedding model. So cool, we're making progress. We need to build embedding models by combining pre-trained encoders. That's the homework for the weekend. And just let's talk about the quick structure of how that will look. So you'll try to collect everything you know about your, let's say, news, right? And you want to keep the types. You want to keep the moderation score and article body and likes and all the different data types. You want to build some ETL pipeline to collect the likes and the body of the news. You want to get this in one place. And somehow you want to encode those different things into the actual vector. Remember, we need to encode the whole news object into the actual vector. So you have to figure out how to do this transformation. And then you have a query, right? And the query has some kind of expectation of freshness and popularity and trustworthiness and the actual query string and maybe the user history, right? The user clicked on some things before, maybe we can use that. So you have some kind of query object that you also have to make a vector out of, and then you match the vectors, right? It's the same idea. And then finally, well, what if we don't know what is the freshness expectation of a specific query, but it just says recent, right? Then maybe we can infer from the actual query that the user in this specific instance wants fresh results. Okay, and actually using a language model for this kind of works. And there are some frameworks at the bottom of the slide which you can't see that help you do that. So you can take a natural language query and infer these expectations to help satisfy the query. And lastly, okay, you cannot have an information retrieval system without a feedback loop, right? You need to somehow figure out how to take in behavioral data. What are the people clicking? What are they not clicking? What did they thumbs down? What did they add to cart? Whatever it might be, you need to find a way to take in those events and update something, right? So that it converges to what the user actually wants. And again, there are some tricky ways to do it. You can build a re-ranking model, but we kind of established that re-ranking kind of sucks. You can apply, recommender system techniques, and you can fine-tune your embedding models, right? Or you can basically figure out, okay, if I can encode the recency and popularity and trustworthiness and the topical content of the data in the vector, maybe I can just kind of boost those different signals at the retrieval time to see if I can personalize the results for the given context or for the given user, right? So some basic stuff. And perhaps when the user clicks on some items, I can accumulate the vectors describing those items and make a user vector to track their preferences, right? Like right side, basic, easy stuff. Left side, questionable ROI. Don't start on the left side. Start on the right side. OK, and in the last 4.5 minutes, I'll talk a little bit about how some of these things can be done in the open source Superlinked framework, which you can go and check out on GitHub. Apache 2, free to use. We would love your feedback. But basically, we talked about how there is a bunch of data sitting in your warehouse and database, and it has all these signals about your news and users and so on. So your first task is getting it out of there, getting it in one place, collecting the data, encoding, making vectors out of it. there will probably be some vector databases under the hood, right? You make beautiful vectors and you put them somewhere in a place where it helps you find similar ones quickly. And then you want to build your use cases on top of it, right? You don't want a solution for RAG or for search or for a recommender system, right? You want a solution that tackles all the touch points with the user and uses vectors to do it and make it smart. So don't think about isolated use cases. Think about the strategy, how to serve the user better or discover the fraud across the different touch points. So that's basically the structure, and we make the box that's in the middle, and it's open source. And I wanted to show you like a couple snippets of code just to kind of make this a bit more concrete, right? We were talking in abstract, and basically the structure of the product is that you define your data, right? It starts with some schemas, with some, let's say news and user and event objects. You define your types, you define your objects, and then we have this concept of a space. And space is basically an abstraction over an encoder, right? Remember, like here, these arrows, right? We were trying to encode different aspects of our data into vectors. And so each orange arrow here is an encoder, right? And we expose those encoders as spaces. So we have, obviously things to encode text and image, but then also numbers and timestamps and categorical data and all kinds of other stuff, because those are the signals that you have about your news. And so we give you the abstraction to basically bind your schemas to these encoders. And then you define an index that's built out of the spaces, right? The spaces come together to describe, let's say, the news from all of those signals. And then you can query this thing. And you can say, OK, here are the different weights with which, in this moment, the user cares about the different signals. And by the way, here is the query text. And also bias this towards the vector that tracks user preferences. So we have a query language that supports this. And if you are kind of listening to me and looking at this and thinking, Daniel, this kind of looks like an ORM for a vector database, then yeah, that's kind of one of the ways I heard this described. You kind of think in objects, think in data. Under the hood, there are vectors, and you can get results, right? And then the thing that we are launching imminently is a server. So we have a framework where you can play with this in a notebook, but using the same declarative interface, you'll soon be able to set up a service that connects to a few initially supported vector databases under the hood and gives you REST endpoints for pushing data into it and running queries. And it does all the compute. It does all the index lifecycle management, right? Think about migrations in SQL. Like, that's a nightmare in SQL without the models. And now think about migrations for a vector database. It's a nightmare. You don't want to be dealing with that. And so this abstracts it away. And then you just, server up, and off you go, building your MVPs. And then, of course, once you have that server, you can hit the endpoint and search for crop yields and do a little boost on recency, right? Because maybe in this query, recency was important. So those are the parameters that you then can search against. Or finally, getting to the first slide of the presentation, where I said, well, but what if we just have a natural language query that says recent news about crop yield? Like, how do we know that recent, requires a boost in the freshness signal? Well, we are bundling that as a feature into the system, the inference of how do you go from a natural language query. You just add to the query object one parameter with natural query, and then you call that parameter a name, and then you just provide a natural language query, which under the hood uses a language model to infer the right weights and execute that query against the data that you have indexed, right? Without filters, without re-ranking and all that other stuff that we sort of agreed that it doesn't work. OK, cool. So basically, that's it. That's what I came to sort of talk to you about. If you are interested in vectors, we have a few resources out there. We have Vector Hub, which has 29 in-depth articles on how to build vector-powered software. We have a table that compares 40 different vector databases. It's a community effort. The vendors are contributing this data. We kind of double-check it. If you are in the market for a vector database, which we aren't, but we work with these people, right? This can help you understand what's going on. And then finally, this QR code has a waitlist for the server. And whoever drops their email in there joins the raffle for the Meta glasses. So If you are interested in building vector-powered stuff, and you are interested in putting a computer on your face, then that's a QR code for you. Thank you very much.